Good day, everyone. I'm Thomas Di Giacomo, Chief Technology and Product Officer at SUSE. The global and total business shift to digital is happening fast and furious, compelling enterprises in every industry to modernize their core architecture and infrastructure while adopting new cloud and edge patterns at the very same time. Every enterprise needs to become a distributed digital enterprise, one that's able to place applications and data flexibly, intelligently, and securely across their entire IT estate. Core, cloud, and edge. They need that to deliver the outcomes and the always-on experience their users and customers demand. Earlier, Melissa shared with you our aspiration to be the most trusted, most secure, open-source infrastructure software provider on the planet. My colleagues, Marcus, Greg, and Basil, have described the unifying infrastructure platforms that bridge the traditional and software-defined modern cloud-native environments and make the always-on digital experience possible. In the next few minutes, I want to show you how we ensure secure interoperability at every level of such distributed software stack, even before the first bit is written to disk, and how the SUSE approach is the only one that delivers zero-trust protection from the software supply chain and developer pipeline to cloud-native runtime operations. To do this, I will invite Erin Quill and Jeff Price to join me and explain that to us in a way a child could understand. Actually, I've got my child here. Arthur, please. Arthur is going to validate that later, that he can understand what we're showing here. Thank you. Now, Jeff, Erin, please join me on stage.
Hey, how's it going?
Hey. Thanks, Erin.
Thanks, Dr. T. Let's start by talking about that cool demo that Basil did in the Edge demo. So if we dig in and really look at the architecture of that demo, what we're going to see is in the front end, there's a pod running Node.js, and it's got an Acri module running, so it automatically detected that camera. We then have a node that's running the AI model, and that's running in Python, and it's got Git running. And then we have a third pod that's really running the database of all current promotions, and that's running Redis. We've got a base that's really built on SUSE technology. As soon as those pods and that application came into existence in our cluster, it automatically inherited a whole bunch of cool benefits. Now, our cluster, if we dig in and see really what's inside, base of it is Kubernetes. And when we start with Kubernetes, we get a couple cool things. First, we get our data plane. We get a database in which Kubernetes is going to store the information. We get a controller manager. We get a cloud controller manager. We get a scheduler. That handles spinning up and spinning down pods and services. We also get a kubelet and the kube proxy. And then we have an API that allows us to talk to all these different modules programmatically. Now, we're just not using any version of Kubernetes. We're using a SUSE version of Kubernetes. We're specifically using K3s since this is an edge solution. And what do we get when we install K3s? Well, the first thing we get is a container runtime. It still blows my mind that Kubernetes by default doesn't contain a container runtime. We also get network completely taken care of. We've got pluggable networking, so you can select your own networking module. We have Ingress installed, and we have DNS, so you don't need to deal with it. It's done automatically. We have Helm, which makes it really easy to install applications. And you get a metric server, so we can start to collect statistics about all of your workloads and nodes. All those are really the core base of our cluster. Now, we wanted to have reliable storage for this application, so we installed Longhorn. And what Longhorn allows us to do is really leverage all the excess storage that you've got sitting on those nodes and use that to create a reliable storage pool that any of your pods can use. Now, as far as security goes, we've installed New Vector, so we get full supply chain security. That means protecting against the known. That's any known hack out in the world, we're going to look for and actively monitor your system to make sure none of those exploits are on your system. Now we've got to protect for the unknown. What do we do if a hack hasn't been discovered yet and nobody knows about it? That's where New Vector's runtime zero trust security really kicks in. We can lock down an application to a specific profile that we create and make sure no unknown hacks take over your system. Now, our cluster is a downstream rancher-managed cluster, and with that, we get a whole bunch of additional benefits. First, we get authentication. We get the ability to plug directly into your corporate network, and what that means is when people go to authenticate to their system, they can use their normal username and password. We don't have to manage all that. We also get the capability to have an open policy agent, which really lets us extend and do some very cool things with Kubernetes, which we'll talk about in just a bit. We get the ability to do backup and restores automatically and whenever you want to do it. We also have the ability to do CIS and Istio very easily and quickly to install. We make logging and monitoring extremely easy to install and take advantage of. It's simple 3 clicks, and both of those systems will be up and running very quickly. Now, let's take a minute and really dig into monitoring and talk about the type of monitoring that we have on this system by default. But before we do, let's talk about what it's like rolling out monitoring without a SUSE cluster. In a classic environment, if we wanted to install monitoring, first we'd have to go install the monitoring software, and then we'd have to go to your servers and install an agent. And not just on one of your servers, we'd have to do that on every single server in your environment. And it's not only your servers that we have to do that with. We have to actually go and do that for applications as well. So you have to go to your applications, you have to install some sort of monitoring software for that. And again, you have to do that for every single application in your environment. What that means is from the time you start to install your monitoring software until you're finished, it takes a tremendous amount of time. This can be days, weeks, or months before you're showing value. And it's not only that, you've added a whole bunch of work log to your employees to update all those servers with the monitoring applications. You've also added workloads in the future. You're telling people that, hey, from now on, anytime you go to add a new workload or a new application to the environment, don't forget to add monitoring. So really, you're adding constant work to the environment. Now, how is that different when we're running this in a SUSE environment? Well, since our cluster is based on Kubernetes, we can leverage a bunch of the power of Kubernetes to do this for us. Specifically, we're going to talk to the Kubernetes API. The Kubernetes API has this cool call called Pod Scheduler. What the Pod Scheduler does is it tracks all pods as they spin up and spin down. So we'll be notified of them. It does the exact same thing for services. So as a service comes online or shuts down, we'll be notified that that service has changed. Now, in our environment, to install monitoring, this is the great thing. It's 3 simple clicks. And the first click is, I want to install this. The next click is options to customize it. Where do you want to put storage and things like that? What IP address do you want to give it? And then your third click is just a confirmation. And as soon as you do that, we automatically install Prometheus. And Prometheus goes out, and it's going to collect all the statistics from your applications, your services, and your nodes. And we're going to install Grafana, which is really going to give you some beautiful dashboards to display all that information. Now, here's what's cool. When Prometheus is installed, it installs and creates a Prometheus operator. That Prometheus operator talks to that Kubernetes API and gets a list of all pods that are currently spun up. So now what's going to happen is almost instantaneously, we're going to see statistics from all the pods in your environment. And it's just not the pods. It's also the services. And anytime a new pod or a new service spins up, we're going to be notified of that, and we're going to be able to immediately track that. We do the same type of things for nodes. For nodes, we create a daemon set, and that says, hey, on every single node in this environment, I want you to install a monitoring agent. So now, anytime I spin up a new node, it gets that monitoring agent as well. So now what can we do with all this information that we're collecting? All of the Prometheus configuration is stored directly in Kubernetes. So what does that mean? Well, first, I don't have to go hunting around to find the server that's holding the configuration file when I want to change things. It's stored in Kubernetes. It's just an object that I can access. In fact, anyone that you've granted rights to will have access to modify that configuration. And when they access it, what username and password will they use? Well, of course, it's their corporate username and password because we connected Rancher up to your existing directory. All of the data that's being collected from all of our applications, our services, and our nodes is going to be sent directly to the Grafana dashboard. So we can do all sorts of cool graphs and displays to really see how resources are being used in your environment and how applications are behaving. We can also leverage that information to generate alerts. You can set alerts that say, hey, if we all of a sudden get a bunch of users or a processor on this specific machine hits a specific level, we generate an alert and notify you that you hit that level. The other thing we can use these statistics for is scaling. So we can scale up and scale down pods as resources are needed. Jeff, let's show them the monitoring capabilities that we get by default just because they came into existence on our SUSE cluster.
Absolutely.
But backing up a second, it's important to understand that monitoring is a per cluster capability and can be installed on each managed cluster, including the local Rancher manager cluster, or any of the downstream managed clusters, like in our example Edge demo cluster here. So as you said, a 3-click install for each cluster that you want to monitor. So after you select a cluster, you go down here to the Cluster Tools sticky menu item. We're going to click this and it brings up a curated list of charts that you can install to manage and maintain your Kubernetes clusters. So let's click the monitor icon and get started. So here we want to actually customize the Helm options so we can add some persistent storage. Obviously, we're storing metrics over time. We probably want that to stick around for a while. So we're going to customize the Helm options. There's a click. Go to the values. Go to Prometheus. Enable the persistent storage. We'll pick the Longhorn storage class we've got set up. Click Next. Everything's ready to go. And last, click Install. Now this will take a couple minutes, and while it's working, you can actually get a status report of as it's deploying that Helm chart here.
And a few seconds later, you've got monitoring enabled for your cluster. How you see that manifested right in the dashboard here.
All right, so you can see monitoring's installed, and it's modified the chart interface a little bit. You don't see the install button anymore because it's already installed. You could delete it, you could edit the actual deployment. And it's also modified the Rancher dashboard to include the monitoring menu item. So monitoring and alerting components are actually set up right here. And it's a very convenient way to get right to some links that'll proxy out and open up new tabs in your browser to bring you to the Grafana dashboards or the Prometheus query language interface, as well as Alert Manager and the rules and targets. So let's go ahead and click on the Grafana dashboard here and see what we've got for metrics so far. So it's been running for a few minutes. We've got some metrics that have been collected. You can also see some speedometer type graphs here that tell you if you're redlining a particular resource or not. CPU, memory, and disk utilization looks pretty good here. We've also installed, as part of this deployment for monitoring, about 30 different individual Grafana dashboards that give you kind of a visualization and metrics on different components of your Kubernetes cluster that you've deployed, different services within it, arrangements of workloads, pods, nodes, namespaces, and those various functions. Tells you some ingress, health, and well-being information, and general node exporters, Prometheus statistics gathering for the individual nodes. So a bunch of things to really, really make it easy to see what's going on with the health and well-being of your cluster. And another really cool part is that, sure, you've got the Grafana dashboards here, but you can also look at the individual components within Rancher. It's also modified the dashboard to give you a metrics tab right within the workload deployments itself. So let's take a look at that. These are the individual metrics for each of those workers that have this ACRI daemon set running. You can see the CPU, memory, and network and disk information for this particular workload. Another cool thing, they've added a link here so that you can jump right over to the relevant dashboard in Grafana. So same charts and graphs represented directly in the Grafana dashboard now. And if you want to modify what the selection is for this workload and pods, you can specify your namespace in the drop down here. You can pick the deployment type or kind of deployment. This is as daemon sets and replica sets in the ACRI namespace, and the individual workload that's represented on the screen. Look at the alerting interfaces here. We have some great documentation about how to get the alerts set up. So if you wanted to go into alerting down here, go into your routes and receivers, set up some receivers for email or integrations with, SMS, PagerDuty is in there, a bunch of different interfaces. There's even full-on integrations with Slack and Teams and things like that. So check our website for step-by-step instructions on how to get those things set up, and you can get some notifications.
Perfect. The thing that I really like about the Grafana Dashboard is it gives me the ability to kind of see the status and health and use of resources for my entire cluster all at the same time, and then I can dig way down to individual nodes and workloads like you were showing.
Another cool thing, of course, Prometheus Grafana, completely open source, but when you acquire those open source projects through our product, we support those. So anything happens or you need help, Prometheus and Grafana is supported just by acquiring them through SUSE.
Fantastic. Now that we've talked about monitoring, let's focus on security. The first part we want to focus on security is really scanning for the known, scanning for known hacks and known vulnerabilities that are out there in the world. So what we do is there's this cool thing called CVE. People around the world collect all known bugs and exploits and pull them together into a central database so that everyone in the world can be aware of those. Now, what we do is as soon as those workloads come to spin up in our environment, the first thing we're going to do is we're going to scan all of the pods and all of their containers to make sure there are no known vulnerabilities. If there are, we're going to make you aware of that. Now, we don't only do that for all pods that spin up in your environment, we also do that for your registry. So we will periodically scan your registry to see if there's any known exploits in that as well. Now, if we do find an exploit, what we're going to do is we're going to bring up and give you the information on that CVE. We're going to give you the details to let you know if there's a fix for that, and if there is, where you can go to get that fix applied. We also plug directly into your CI/CD pipeline. So now anytime one of your developers submits a piece of code and it goes to build, we will automatically scan that build to make sure there's no vulnerabilities in there as well. Let's take a look at deep packet inspection. Deep packet inspection gives us the ability to really see what's going on the traffic in the network. So first, it gives us the ability to see traffic inside of the pod. So we see exactly what's going on in between these two containers that are sitting in a pod. We also have the ability to see traffic in between pods. So here, we're seeing traffic in between the front end and the AI model. And when we see the traffic, what we're actually seeing is we're seeing, oh, the AI model is communicating with the front end over port 8080. And what we're going to do is we're going to actually make a note of that. So we're going to create a profile that says the front end spoke to the AI model, and we're going to note that port and protocol that it used. Now we're going to do the same thing when we see the front end talk to the database. But this time, we're going to dig deep in and really take a look at what's going on. So now we have packets that are going in between the front end and the database, and we see those going across as just ones and zeros. But with deep packet inspection, we have the ability to understand several protocols. So rather than just seeing ones and zeros going across the wire, we can actually identify that as Redis traffic and then give you the exact command that was going across. So you're seeing in text, Redis made a get current promotions rather than just ones and zeros. It's a lot easier to diagnose problems with that. We also use that capability to look at exactly what's going on in your network to make sure there's not any known hacks that are going on. There's a variety of different exploits that leverage the network to take over your system. So what we're going to do is we're going to be constantly looking over the network to make sure none of these known exploits are there. Now, since this application is in a kiosk that's sitting right next to a cash register, there's a good chance that it's going to have some sort of compliance and policy that's put on place because it's coming close to credit cards. What we can do is we can use this deep packet inspection and really look at what's happening with the traffic. So if we see a packet going from the front end and heading out to the internet, we can actually look inside that packet and see, wow, that's actually a credit card number, because we're looking at the data, and we can say, poof, kill that credit card transaction from going across the wire. monitor and notify us that something happened, give us the IP address that tried to do it, and let us know they tried to move a credit card out of our system. We can do the same type of thing for processes. So we're looking at all processes that are running in that pod. So let's zoom in and take a look and see exactly what's running on the AI model. So on the AI model, we have Python 3 running. So we're going to make a note of that in that profile sheet and say we saw Python 3 running in the AI models pod. We're going to do the same thing when we see the git command run. And we're going to make a note and say we saw the AI model run the git command. And we're building a profile that shows us exactly how this application behaves. Let's talk about the new vector architecture so that we can understand exactly how it's able to do this. The first component in new vector is their controller. And what the controller does is the controller has the ability to talk to the Kubernetes API just like we did when we installed monitoring. In fact, it's using the same Kubernetes API to be aware of all pods that are spinning up and down, as well as all services. So that really gives us a good feel for the majority of things that are happening in your environment. Now, you're typically going to have 3 of these controllers running in your environment, and they're just deployments. The next thing we've got is the scanner. And the scanner really contains everything that's needed to go out and look for those known hacks. So what's going to happen is every 24 hours, it's going to go out and grab the latest CVE database, download it to that container, and from that point forward, that container is completely self-encased. It's got everything that it needs to do the scanning and has the ability to scan every container that comes online in your environment, if you wish, as well as all of the containers that are sitting in your registry. Now, the third component is the enforcer. The enforcer is something that we run on every single node in your cluster. So we create a daemon set, much like we did with monitoring, and run that on every single node. Now, let's dive deep and see exactly what's happening with the enforcer. The enforcer sits in between the pods and the processor and the network card. So now what happens is when we see a process come down and want to talk to the processor, the enforcer makes a note of that. And it says, oh, I saw the AI model make a Python 3 call. Now, when we have a network call, the same thing's going to happen. It's going to see the network call, go directly to the NIC. The enforcer will notice it and make a note of it so that now we have a collection of all processes and all network calls that this application has made. The great thing is we can really use this enforcer to be a source of truth for what pods and containers are running on your nodes. Like I said earlier, we do use the Kubernetes API to be made aware of all pods that are spinning up and down and all services that are spinning up and down. But there have been exploits in the past that have allowed people to spin up pods on Kubernetes without the API knowing. Because the enforcer sits in between the processor and the network on the node, we're aware of every single pod that spins up. That means if there's an exploit that allows somebody to spin up a pod that the Kubernetes API doesn't be made aware of, we'll be able to notify it and we'll be able to track it. Jeff, let's go ahead and show what kind of capabilities we get because this came into existence in our cluster.
Absolutely. So I've got new vector installed here. The first thing you see when you fire up is the new vector dashboard.
So before we get too deep into the dashboard, real quick, something to note is we've included the new vector chart in the cluster tools. So you can install it just as easily as we did monitoring by using the chart located here. And it will also modify the menu, giving you a single sign-on type of jump point here, integrating the credentials and pass through there. So back in the new vector dashboard, first thing you're going to see is the security risk score. And this is a number just assigns based on issues that you might have from a vulnerability perspective, ingress and egress exposures, anything that is identified already. It also gives you some highlights, top events, top issues, vulnerabilities, things you might want to check out to get started on tightening up your cluster from a security perspective. Also gives you some tips and tricks on how to improve your score. So right through the UI here, you can kind of follow along and get some ideas on how to reduce your exposures, your exploits. All right, so we've just installed this and we haven't locked anything down yet. So our security risk score is less than perfect at this point. But once we've leveraged NuVector and its capabilities to discover our workload traffic and the processes and those characteristics, and we've flipped some policy modes over to monitor or protect, our score is going to improve greatly. So as Dr. T and you mentioned earlier, we've been talking about secure software supply chain. So let's take a look at how NuVector integrates the vulnerability scanning pieces as just one part of securing that chain. Let's go into the assets menu here. NuVector organizes things into an assortment of assets. Platforms are the Kubernetes clusters themselves, the nodes where the individual components are running, the enforcers, containers, the actual workloads that are deployed in your cluster, and registries, the sources by which you would install some of those workloads into your cluster. So each of these asset types can be scanned for vulnerabilities. So you can do a security scan. The scanner is built in. It's going to highlight any identified CVEs and publish risk scores, both version 1 and version 2. Give you a general indication of severity and information about known or fixed versions of packages and libraries within a particular asset. Let's take a look here in the container section. You can see some scans that have finished and note the vulnerabilities that have been identified. We've got same deal with our registries, scans that we've kicked off here for the Rancher folder on our Harbor registry, where all of our images are stored. And if you had, for example, a security issue, or a security team came over you and gave you a CVE, they wanted you to help them understand the risk or exposure, you can go into the vulnerabilities menu under security risks and do a search for a particular CVE. Let's do one that everybody remembers, the log4j. I think it was 44228. There it is. So definitely a high scoring vulnerability. However, our impact isn't that great. And that's because the only image that identified with that, that potential vulnerability was this open Zipkin image. And according to the legend here, that's not being used right now. So it's a lower impact than you would imagine for such a high scoring CVE. So there are a lot of benefits to scanning and securing parts of your supply chain from all the way from the image sources down to your deployments. And you can get some details on where those problems are and what you can do about it.
It tells you the exact version that you need to fix that specific exploit, so you know what you need to go and find.
And usually it was fixed in this version, so this version or later is going to be okay.
Fantastic.
And you can see an example of that here in our registry scan results. Down here, you see the AKS operator version 1.0.5. And it's got some issues, and you can see which layers of the image are having those issues and identify those particular vulnerabilities. And it even shows you some versions here and the fixed versions and when those were published. Another good thing to do is to turn on your auto scan capability. That way, any new workloads or nodes that come into the cluster are going to get scanned when they're deployed, and any updates to packages or libraries, if they're applied, or when the CVE database gets a nightly update. So you can just turn it on and you're set and ready to go. NuVector also provides an indication of compliance. So according to a set of regulations or industry standards, you can actually take a look at the compliance profiles here. We've got some included for PCI, GDPR, HIPAA, and NIST. So in addition to those, we've got general security recommendations and standards. So, okay, great. So we can scan our stuff and see where we have issues, take specific steps towards fixing any known threats and vulnerabilities. But let's dive into some of the other features that really differentiate NuVector. Moments ago, you were describing the profile sheet of a workload, where NuVector gathers the process and network behaviors of a running workload and then lets you wrap that protective layer around them to deny the unknown threats. So over in the policy section, we have groups. This is where we can refine a profile or a workload for network or process rules that have been learned. And let's show you how you can easily protect a workload. So first, let's find one of our edge demo containers and see what NeuVector's already found out about it. So here's the edge demo Redis master. And then down below here, we can get a review of the process rules. These are the actual known processes that it's seen firing up within that container. And you see things like CP, awk, and bash, and others. And if I shell into a container that's still in discover mode, we can see this process list get updated by anything I would invoke at that command line.
And if we could also see what's happening with traffic, so we can see actual traffic between the network?
Absolutely. What's cool is you can bring up the network activity. It actually learns the communication, the pipes between the individual workloads, and shows you graphically what those workloads are doing.
Here's the network activity map. So all of the icons on this map and the traffic connections that are displayed between them are interactive. Let's first display the map legend so you can understand what these icons mean. Here you see that things are kind of color-coded and have a distinct iconography. You can tell that most of these are absolutely still in discover mode. So any one of these icons you can highlight, bring up a context menu, and see some details about the workload. This gives you an idea of any network rules, what vulnerabilities have been found for that container, communications that it's had, general information about this workload. Here also you can see the lines between the individual containers or out to IP address or an external network. Clicking on those gives you information about the communication that's occurred. If I can find the Redis workload here, I can see the communication that it's had between other pods and even out to the internet. So since we just curled a file from GitHub, I can see that it had a client, source, and destination. And that destination is located in the US. And if I click on it, it pulls up the whois registry, telling you who's registered that particular IP, what domain it goes back to, and who owns it. So here you can see, definitely learn that GitHub was the target. And if I want to remove this as a rule, again, something I don't want normally to be allowed, I can use the little magic wand here, clear out that network conversation. It removes that from the map. And now we've got a, again, known set of good processes and good communications that are on our list.
Now, we haven't locked this down at all. It's still in discover mode. Now, we'll show you next what happens when we move it into a monitor or protect mode.
The key is you didn't do anything special for this workload. It literally just started to happen as soon as this workload was brought up. It just started to discover network, it started to discover processes, and everything that's going on.
Correct, and that's a big part of locking down and securing a containerized environment, is having a sense of what's running on those, what's good, what's bad. Once you've ascertained what those processes are that are good and wrapped a firewall around it, then you can actually lock it down so exploits that it doesn't know about or that haven't been created yet aren't available or aren't allowed to run on this particular workload.
That's cool. So what we've really done so far is we've shown the monitoring capabilities that we got just because we exist in this network. We saw the default security that we're getting without any customization just because it came to exist in our environment. Now let's take a couple minutes to talk about how we know the node is secure. As Keith Basil mentioned in the Edge keynote, we're seeing systems move out of the data center where they've traditionally been and move closer to where we actually need the work done. In this example, we're going to be in a kiosk that's embedded somewhere in a store, but we're seeing workloads move even farther. We're starting to see them in windmills and very remote sites. We're starting to see them in automobiles. And when you start to think about automobiles, think about what you need to do before you can update the software. We need to do several things to make sure it's reliable and not going to cause any problems. And we're starting to see workloads move into actual dangerous locations where it's not only expensive and difficult to get people up there to work on the machines, but it's actually dangerous. You have to have somebody certified so they don't get injured. In order to do this, we really need to look at the workloads differently. Since these are going to be in remote locations, the first thing we need to worry about is physical security. This is one of the things that Keith Basil showed in his keynote. He showed TPM, the ability to make you authenticate to the machine before you can even start to do an install. That means before you can write bits to the disk, we're securing the box. And only after you've authenticated are you allowed to install an operating system. And that, of course, also takes place after you've installed the operating system to give you a secure boot. So if somebody comes in and swaps out a hard drive or swaps out a component, the system will lock down and not allow it to boot so that you can then correct the problem. Now, let's talk about the operating system. If we've got an operating system in these remote locations, we really need to make that operating system rock solid. In fact, what we've done is we've created a new operating system called Sli Micro. And Sli Micro's goal is to really treat the operating system and the computer as an appliance. You turn it on and you know it's going to work no matter what. What this allows the customer to do is to really just focus on the application and not worry about the underlying infrastructure. We do this by making Sli Micro extremely easy to install and deploy. It's incredibly easy to update. It's easy to manage. And by default, it has security turned on and is locked down. Now, Sli Micro uses the operating system a little bit differently than we have in the past. What we're actually doing is we're booting to a read-only disk partition. This has a couple huge advantages. First, we know every single time that machine reboots, it's going to be exactly identical and you're going to get the same experience. The other thing is if we're dealing with tens, hundreds, or tens of thousands of machines all around the world, we know they're all identical. We do health checks so that when that operating system boots up, we check to make sure that partition is good, everything's going to boot, and everything's rock solid. Again, secure by default. Sli Micro is built from the ground up with security in mind. We also have the ability for you to take care of SUSE's live kernel patching, as well as the real-time kernel. Now let's take a minute to really talk about how Sli Micro works and how we're able to update a read-only operating system. So what happens is all updates, changes, and patches that you want to apply to the system are bundled together into a single transaction. That single transaction is downloaded to the node. Then what's going to happen is the node's going to make an exact copy of the current read-only partition. It's then going to enable that partition temporarily. You're still running on the live read-only partition, but it's going to then move all of those transactions over to that copy that we just made and install them. Once it's installed it, it's going to do a full health check to make sure everything's good. If everything's good and it passes its test, the next time you reboot that system, which happens very, very fast on Sli Micro, we will boot off of that new image. If the system detects a problem on boot and there's something wrong with the partition, the great thing is we can easily roll back to a previous version. Not only do we have the previous version, we have several previous versions, so we can always step back to a known good system. This really gives us incredible reliability, especially for these far remote locations. Now, we know the node's secure. How do we know the container's secure, the place where all the code actually resides? Well, we've done some very cool things at SUSE. We've created these new things called base container images. This allows you to build a container off of a SLES operating system that we know is rock solid, secure, and enterprise grade. The first one that I'm going to talk about is the base container. This is an image that's about 45 megs and really gives you a nice base for any common deployment you've got. The next is what we call the minimal. We've really pulled out a lot of tools. This is less than 15 megs. It's very, very small and just gives you the basic tools to get up and running. And then we have micro, and micro is tiny, less than 10 megs. This is if you want to start with an absolute small container and build it up with only the components you want. Now, not only do we have these containers that just start with a clean operating system, we also have several purpose-built containers for you. For example, we have one with Golang. So as soon as you download this one, you have Go up and running. We have the same for Node.js. We have one for Python. We have one for Rust. We have OpenJDK and an OpenJDK that's got the developer edition installed with the SDKs and several flavors of Microsoft. We have Microsoft.NET. we have the Microsoft .NET with the SDK, and we have the Microsoft .ASP.NET. Now, how can we use these containers? Well, what's cool is we actually use these containers to make sure the deployment of this custom app was solid and secure. What we did is on the front end, we just went and pulled the Node.js container. So it automatically brought down a system, secure, reliable, that has Node.js installed and the developer could start to go. They needed one for Python, so all they needed to do was call the Python container, and they start with a clean, solid, secure Python environment to work with. For our database, we don't have one pre-built for Redis, so what are we gonna do? We're gonna grab the Sli minimal one and build our image off of that. Now, in order to make this really easy for the developer and to get the developer up and running in these images easily and developing in Kubernetes easily, we've done a couple cool things at SUSE. One of them is something we created called the Rancher Desktop. What the Rancher Desktop does, it allows me to literally just drag and drop the Rancher Desktop onto my machine, and within minutes, I'm gonna have a full SUSE K3s cluster up and running, and I can start to develop. Jeff, let's show them the experience a developer gets by using Rancher Desktop and these BCI images.
So as Aaron mentioned, really quick and easy, Rancher Desktop installs on Mac OS, Windows, and Linux. Super easy. Head out to our web page and you can get an idea of some of the integrations with VS Code, how easy it is to get going. There is full docs and some how-tos at docs.rancherdesktop.io. Head out there, take a look of how to get things running. I'm going to show you how I use it in a little different way. So Aaron was mentioning the base container images. What we have out on the website is at registry.suse.com are all of our base container images that you can use. They're available right now. I'm going to use an example. I'm going to pull down a Node.js. So here's the Node.js. We have a bunch of versions, 12, 14, 16. I think the latest here is latest, of course, but 16-7.55. In my Docker file, I'm going to grab 16-7.53. I can do that from a command line here. We're going to just do a Docker build using this Docker file. Pulls down that image from registry.suse.com. All right, now we have our image built. Let's see what Docker says about its images. There it is, SUSECON 22 BCI demo. All right, what we're going to do next is we're going to actually deploy that, but instead of just using Docker as a target, I'm going to actually deploy this to Kubernetes. So I've got a YAML file, which is a deployment. We can take a look at that here. Something to note about your deployments, if you're going to be sourcing things locally, you don't want to pull your images from a registry. You notice I didn't tag or push that image. So what I did is I changed the deployment. Its default is to do a, pull always. What I did is I changed the actual deployment method here in the spec file to image pull policy to if not present. You can also say never, but either one will work. What that'll do is look locally for that image to deploy it. So I called my image SUSECON BCI demo. So we're actually going to run this deployment. I'll use kubectl command to do that. All right, created that deployment. So I should be able to see that pod running. And there it is running. SUSECON 22 BCI demo and a random set of numbers. Excellent. You can also see that deployment in the Rancher dashboard. We include a simplified version of our Rancher manager just by going into Rancher desktop up here in the tray, hit the dashboard. It kicks off a dashboard. And let's go to our deployments under workloads. And there it is in the default namespace. Excellent. Really simple to get running. I deployed that image that I used a base container image to create and deployed that into Kubernetes. Well, I guess the last thing to do would be to make sure it works. So let's head over and open a browser and localhost 4200.
Now, Jeff, there's one other thing I'd like to have you show me with Rancher Desktop, because this is honestly one of those pains that I hit day to day, right? I'm always playing with a bunch of different clusters, all running on different versions of Kubernetes. And one of the biggest pains for me is I've got these deployments that some of them I built a couple years ago. Right. And it's always a struggle that when I take them from an older version of Kubernetes to a newer version, of trying to validate that I've got the right API calls, that a lot of them have gone from alpha to beta to deployed, and that's always a big thing, is testing my deployments.
Yep, as they say, deprecations happen.
All the time with Kubernetes.
Yep.
In Rancher Desktop, on the Kubernetes setting, you have this drop-down that will give you a whole bunch of versions of Kubernetes to choose from that can be deployed as your base for Rancher Desktop. Nice thing about that is, say your production at work is running on a version, that's different than the latest. You can actually set up your development environment, again, on the go, using the Kubernetes environment that makes sense for your environment. I'm running 1.23.5. It's not the latest. The latest here is noted as version 1.23.6. So I'm going to actually select that, and we'll see what happens. All right, gives you a prompt. It says, hey, you're changing from 1.23.5 to 1.23.6, and it's going to upgrade Kubernetes. You want to go? Let's go. So it's checking any images it has, and if it doesn't have that version, it'll download it. Takes another few seconds to start up this different version. Again, wait for the API to become available. Start the services. All right, that was it. Pretty painless upgrade. All right, so after the upgrade, let's just go and check on our deployment. So we'll go back to the terminal, do a kubectl get pods, and there's the SUSECON BCI demo still running. Let's head over to the Rancher Dashboard, and there it is, redeployed on the upgraded version of Kubernetes.
And that's what I absolutely love, is that it shuts down your current deployment, upgrades Kubernetes, and then brings that deployment right back up. That is just fantastic. Key thing we want to talk about now is how do we protect from the unknown, from things that nobody in the world has seen an exploit before, which happens every single day. Throughout this entire demo, we've been building that profile that shows exactly how the application works, right? We tracked all network traffic, and we tracked all processes that we're running. We can take that profile and use that profile to really create security as code. So it becomes very, very easy to save security, edit it, and move it around between multiple clusters. Let's talk about how this works. So we've got that profile that we built. What Jeff's going to do is Jeff's going to simply flip a switch, take it out of the discovery mode that it was in by default, and turn it into monitor mode. So now that it's in monitor mode, what's going to happen is when we see that Python 3 call come, the enforcer's going to see it. It's going to immediately check on that list and say, Python 3, we know about that. That's cool. Go ahead and let that application run. Now, when somebody goes run a curl command, which was not in that list, since we're in monitor mode, what it's going to do is it's going to let the curl command run, but it's going to generate an alert, and it's going to actively notify Jeff and say, hey, Jeff, somebody on this pod just ran this curl command just to make you aware. Now, that's cool. That's really nice. But what if we really want to lock things down and we just don't want to be notified? We need to make sure nobody actually takes over one of our systems. So what do? We put it in protect mode. Now that it's in protect mode, again, it sees the Python command. It says, no worries, Python's an approved application. We'll go ahead and let it run. This time, however, when it sees the curl command, it's going to immediately look at the list and say, that is not on our list. And it's going to go poof and literally just throw the process away and not let it even hit the processor. And it's still going to notify Jeff that somebody ran the curl command. Jeff, let's show them how we can take this profile that we've been building and really create zero trust security to stop us from being vulnerable to unknown hacks.
Yeah, absolutely. All right, so back into the new vector environment. I've selected the Redis workload here, and you can see all of the processes that are known. These have been discovered. So what I want to do is I want to put this workload into a monitor mode. It's still not in a lockdown mode, but it will alert us if there's any changes to these processes. So I simply select this particular container, go into switch mode, select monitor, submit. It says, hey, do you want to change the policy? I sure do.
Yep.
So at this point, now it is monitoring this list of processes. Anything that deviates or is not known, it'll send us a security alert. So let's go into the container itself. I've got a shell over here in the Rancher dashboard, and I'm going to try and curl a file from GitHub.
Cool.
Okay. So here's one. They're checking the worker. It's actually one of the new vector utilities. So cool. It pulled it down.
Yep.
Do I see anything on the new vector? So I can refresh this. Since it's in monitor mode, it's only worried about these processes. It knows these are good.
All right.
So now I can go into notifications and look at any events that have happened. And it says, oh yeah, right up here. A process profile rule violation by command curl on the container Redis, blah, blah, blah. So right here you see and can get information about who did that, when it happened, and you can actually get a notification back. So anything that is not allowed or isn't been profiled already in Discover mode is going to throw an error.
And one of the key things is, though, it let the process run. Why would you do that? Why wouldn't you just stop it from working?
When you're profiling an application, you let it run, it discovers those things that are known, and it comes up with its list, and it tries to auto-create this profile. Sometimes you don't catch all the things, or you want to actually exercise these applications, these containers, for other processes. So this could be something that you want to add. You'd put it back into monitor, do the curl command, it would be added to the list, then switch it back into monitor. Then it wouldn't be an access violation because it was a discovered and known good process versus a errant process.
Well, and the nice thing is, when you're building out these profiles then, this really gives you a good chance to test it in production and not stop something from working, right? It will notify you. So this is kind of like that first stage that you were doing as you were trying to lock it down for zero trust, right?
Exactly, exactly. You're still wanting to profile your applications. You're going to put it in monitor mode. You want to be notified when there's something that is different, but gives you a flexible position to be able to say, yep, that's good. Nope, that's not bad. So we'll go back into the rules again, go back into the groups. We'll select the Redis container again. What I can do is actually put this into protect mode. And while it let me curl previously, once it's in protect mode, and again, this curl process is not on the list of known good behaviors, I go back into, and I try and run curl.
Poof, the command just went away. It didn't even hit the processor.
That's right. And just for fun, I switched the mode of all of the containers over to protect mode, and look how that affects our security risk score. Pretty cool.
And that's what I love. We literally stopped it from doing anything on that pod.
This is zero trust.
Absolutely.
I don't trust curl. It's not part of my profile. Everybody out of the pool.
And this is really where we were talking about with zero trust, where you have just locked this down to that exact profile. It doesn't matter if somebody has an exploit that can do something on this container, does it?
That's correct.
It's locked down.
Yep.
Fantastic. So with that, let's call Thomas back up to the stage.
Thanks, Jeff. Thanks, Erin. I have to say I had limited trust in your ability to teach me how to do cloud-native security and monitoring, but I have to admit that I think I understood now.
Fantastic.
Now, the real test is the child test, right? So let's see if we are passing that test. Arthur? Did you understand what Jeff and Erin have demonstrated on the computer to do cloud-native application deployment, development, security, and monitoring? Yes? Say yes to everyone? Cool.
Fantastic.
Now, if you want to learn more about all of that, we have follow-up sessions during SUSECON on Rancher, K3S, Sli Micro, New Vector, and Sli BCI as well. So you're very welcome to join them. Thanks again for coming today. Thanks to Erin and Jeff for all the preparation and the work on the demos as well.
Thanks.
Excellent. Thanks, Dr.
Thank you.
Awesome.